Okay, guys, so we're going to be going over assessment question number 7A. And the question asks, a disk with mass 1 is equal to 2 kilograms is spinning in a circle of radius 1.2 meters on a frictionless table. The top rope attached to it is connected in a hole in the table to a block of mass is equal to 3 kilograms. With what angular velocity does the disk have to rotate in order for the block to maintain its height? So to start this problem off, we can go ahead and start writing down what we do know. So we have mass of disk equal 2 kilograms. And we have radius equal to 1.2 meters. Mass of the block equal 3 kilograms. And so we can go ahead and just start drawing free body diagrams for each of the objects. So we have here our block, and we have right here our disk. And so the block is, we want it to maintain the height, so we want it to be at equilibrium along the y-axis. So we're going to have a force of gravity and an equal force of tension of the same magnitude. Now, since we have this tension between the block and the disk, it's going to run constant. So we're going to have this disk right here. We have this force tension pulling on the disk. Now, since when we rotate an object with circular motion, we have to have a centripetal acceleration to keep it from just launching like wherever. And this centripetal acceleration is actually perpendicular to the center of the circle. So this force of tension is actually equal to our centripetal acceleration. So we can go ahead and write an equation for this by saying tension is equal to the mass times velocity squared for the radius. And so this right side right here, this right here is just our centripetal acceleration equation. And so for the block, since the tension has to be the same magnitude as the force of gravity, we can go ahead and just replace this, the left side. We have this as mg, sorry, let me mark this as m2g is equal to m1 v squared over r. And so now we can go ahead and simplify this. In terms of circular motion, velocity is actually equal to angular velocity times the radius. Let's go ahead and replace that. Squared r. And then we can just go ahead and simplify for angular velocity, since that's what we're trying to find. We'll have angular velocities squared is equal to second mass times gravity divided by mass 1 times the radius. And since this is squared, we can go ahead and just take the square root of this. And what we have is our equation to find the angular velocity needed to provide a centripetal acceleration that offsets the tension. So go ahead and plug in our values. We have 3 times gravity divided by 2, 1.2. And what we end up with is 3.5 radians per second. And so this is going to be the required angular velocity in order to maintain the block's height. I hope this helps, and I hope you guys learned something.